Hi everyone, welcome to another tutorial video. In our today's video, I will go over how to download the RGB bands from a satellite 9 image using Python. So let's get started. So the first thing that we need to do is create a new Jupyter notebook. So I will call it Landsat 9. It will be the part 3 in this case. So I will be using the same area and the same region of interest that I used in previous video to download the RGB bands, basically the bands 4, 3, and 2. So the first thing that we need to do is to import the essential library that we're going to use to do this process. So it will be Earth Engine, the request to download the data, this zip file library to uncompress the data. The its array, in this case, to read the data. Let's use its R. The globe library to read all the data in a single folder, and to plot the file, let's use matplotlib. By plot as plt. Is request with s. Okay, so the first thing that we need to do, as I mentioned in previous video, is to authenticate the Earth Engine, which will allow us to download the data. Then, so if we go back, okay, so if we look for Landsat 9 on Google, so we should be able to get this information. So this is the image collection that we're going to use to download the data. The pixel size is 30 meters, as I mentioned in previous video, but we need to use this scale factor to convert the raw radiances into actual radiances. And so let's filter some data. So Landsat, let's create this variable Landsat 9, and let's call the image collection, which is this one over here. Then let's filter the bounds. Filter bounds, and it will be let's use the same geometry that we used before. So it's an area, rectangle area around Manhattan. So BBOX. And let's use the Earth Engine to define the geometry, that rectangle, that area. So geometry, rectangle, and let's use the same coordinates as the previous video. So minus 2403, 40, 69, minus 73, 91, and 40.88. So I missed period. So now, as you can see, this is a minimum, and these two correspond to the minimum longitude and latitude, and these two correspond to the maximum longitude and latitude. So now I can call this over here. So I just want to filter that specific area. Then let's filter the date, which will be, let's filter a clear image for the year 2003. So let's use, this is the start point and the end point will be December 31st. And let's sort these, all of these images by cloud cover, and finally, actually I done, yeah. And finally, let me just put these periods over here and delete over here. And finally, what we need to do is choose the first clear image. Okay, we did this. Then let's scale this image based on this function that we used before. So let's call the function, and over here it will be the image. So we just scale the radiances from this file into the real ones. And then what we need to clip is this image. So before doing this, so as I mentioned in the video, so we our goal is to download the RGB bands. So now what we can do is just call this image that we scale and use the function select and select the bands that we want to choose. In this case, the RGB band. So if we go back to the website, it will be band 4, 3, and 2 RGB. So red, green, and blue respectively. So will be surface reflectance before. Then I need to let me just copy and paste this over here. This one will be the third one, this one the second. Now that we selected the image, sorry, the bands, we can clip the image. So bands by using the area that we defined previously. So if you want to see in detail this area, so you can look for, I will put the video in the description that talk about how we ended up using this area. RGB bands, clip. And then we need to pass over here the rectangle. And now what we can do is, so let's download the data. So let me just create this markdown cell, downloading the data. So, and for this, we need a couple of things. The first one is, let's create a dictionary. So download params. And it will be a dictionary that specify the region. So in this case, for our case, it will be these Manhattan coordinates. What we can do is just call this variable. There's a function getInfo, and let's just get the information, just a coordinates information. So coordinates, comma, then the scale. So as I mentioned before, if we go back, the pixel size is 30 meters, so the scale should be 30, but you can choose any value. The projection, the common projection for this kind of files is WGS84, which is EPSG 4326. And finally, I missed a comma. And finally, we need to put the file format that we want to use, that we're going to use for when we are downloading the data. In this case, I like to save those information, those bands into a raster file. So I'm going to use geotiff. So now that we just defining the parameters, we can actually download so let's first create like download the data. So just from the satellite image, those informations, that specific image, those bands, those 3 bands. So let's create a download URL, and it will be so we can either pass this image, sorry, this variable or this variable. So we clipped this information before. So if you clip the original image based on the rectangle area, so you can delete this region line. But because we defined this region over here, so let's use the original image, which is this one with those 3 bands, R, G, and B. So red, green, and blue. And let's use the function get download URL. And over here, we need to specify these parameters. So I'm just gonna copy and paste this data. And this will define a link. So now what we need to do is download this information. So we can use the variable request. So request get this link. And what Python is doing is basically getting the link and going into that link and downloading all the information. And this into this variable. So we what we are doing is technically we want to download the information, but we are creating this response variable to storage the link, which contains the actual files. So we just over here we just open the link, but now what we need to do is download the information, those 3 bands. So now what we can do is create a path, a zip path. So this variable will contain the name of the zip file that we're going to generate. So Landsat 9 RGB. Let's name it. Let's use this file name, and we're gonna like compress all these 3 bands into a zip file. And let's use with open. Let's open the zip path. Let's generate like a zip file. So with this name, so I'm using this open in within the parentheses the name of the file, and it will be, I'm generating one, so it's like a write file. I'm writing a file, and I name it as F, and then I'm using the function write to get the content from this link. So it will be content. Again, these 3 lines generate a zip file, get the link, all the content in the link, put it in the zip file, and then you will see your zip file in the folder where is located the Jupyter Notebook. You'll see. So the size is 2.9 megabytes. And this file contains the data. So if I go to the folder, so let me just find the folder. Perfect. So if I go to the folder, if I compress this data, so extract all, extract and open dates folder, you will see the bands. So 4, 3, and 2 for that specific image that we found. But we want to do all of this thing in Python. So let me just delete the folder. And what we are going to do is, now that we downloaded the data, so let's open the data using Python and let's generate the image using Python as well. So let me call this reading and extracting files. So now what we can do is, let's create this folder. Let's say information. So this will be a folder we are creating with OS, that library that we imported previously. And we're going to save those files that we are going to extract from the zip file, those raster files, into that folder we are generating. So let's just put exist. Okay. Equal to true. So we just created this folder over here. It's empty, as you can see, but we are going to extract this information and put information inside this folder. So let's use with, let's call the zip file. So it was zip file, the function zip file that we imported, the library, and then the function zip file. And then we need the file name, which is this one. And then we are going to mention that we are going to read the file. In this case, we're not generating a file. We're just reading a file, an existing file. Let's use this name, and then let's call this name and use the function extract all and give the location. So it will be in this library, in this location. If I run it, so if I go inside the folder, now you will see those 3 raster files. And now what we can do, so let's read those. So let's read the file and generate an image. So let's read those 3 files. So just get the location of those. In order to do that, we can use sorted globe and pass the information. So the data is, let's use F, is located inside this folder, which is this variable. And let's just read all of them. We already know that there are T files, so let's read all of them that contains at the end this T extension. And I forgot to close the parentheses. So if I put this over here, you will see those are our 3 files inside this folder. So this is the location. So now what we can do is generate empty array and create a for loop to go over each of the path. So this variable, we are going to open those and we are going to append those into or add those data sets into this list that we are creating. So let's define this variable to read the files. So open data set. Over here, we're reading each of the file. So in this case, this path variable, and the engine will be raster. And let's use a squeeze to get just the band. straight the band information. So technically the array and everything. So the array in the location. So it will be the array information, the longitude, latitude. I will show you this later. So let me just complete this. So let's use this. Let's call the list, append, and let's append this. So if I just open the S, so you will see that we just opened this. It contains one band. X is the longitude values. The Y are the latitude values. This is spaced reference, and this is the data, the actual data. But if I use length, it might pass this variable. So you will see that the length is 3, which are those 3 bands that we just read. So now we can just generate this variable over here, use its array, and use concat, this function, to concatenate those 3 bands into just one file. So let's call the list with the actual bands. And just to let you know, it should be good for you to print the actual location. So you will see that the first that was saved was the band 2, then following by the band number 3 and band number 4. So that's why at some point above over here I used sorted to sort the files. That's why we see from 2 all the way to 4. And then the dimension that we are going to concatenate is the band. So if I open this DS, so you will see that we are interested in this variable band. So it will be band. So now if I open this variable, you will see that the actual variable has 3 bands with these dimensions. And the order of the bands are this one. So the first one is 2 or red, the second one green, and the third one blue. Okay, so now what I can do is so let me so here it's appear like band 1 1 and 1. So just to get track that of the order of the bands, so we can just call again this variable and use assign course. Let's call the coordinate bands, call band, sorry, and then let's replace those by so the first one will be B2, the second one B3, and the third one B4, just following the same order that we printed over here. Okay, so now if I call again the variable, so you will see band 2, 3, and 4. Those are the 3 bands that are here. So now what we can do is let's make up a simple plot just to see. But right now, so the RGB bands. But right now, so you can use these files if you want to, or you can either save this file and read it into QGIS. So let's see. Let's say, sorry. So now if we want to generate an image, so we want to RGB bands, and we need to pass the order. So RGB, which is B4, then B3, and then B2. So that is the order we want to print. So the RGB subset will be this variable, but let's organize them based on the order that should be R, G, and V in this order. Let's follow. So let's select this. So now if I just like see inside the variable, you will see we change the order. So now it's B4, B3, and B2. So now what we can do is get the array. So RGB, the array. So it will be this one over here, and we are going to call, so let me just show you again, this variable band data that contains the array. So band data. So now if I plot this, so you will see the array. It has this shape, 3 bands, and this is the information of the columns, numbers of columns, numbers of rows. So you will see over here numbers of rows and numbers of columns, and how many bands we have. So now what we can do is, let's make sure that this has a projection. So Rio CRS, yes, so 43, 26. So now we can create the figure. So it will be fig AX. It will be a simple figure just to show the natural image. So fit size 4,6. So let's call the array, and let's use plot plot imshow so RGB equal to band. Let's define these parameters, which are essential, and according with also the manual, we will need to print just the minimum, set the minimum and maximum value for visualization purposes. So bmin will be 0 and bmax will be 0.03. We can save the figure if we want to. So plt save fig. So will be Manhattan RGB PNG. Okay, this is supposed to be inside quotation marks. Inside quotation marks. Then DPI will be equal to get the high resolution of the image, and let's use BBBots inches equal to height. I need to close quotation mark and plt show, and this is the image. So you'll see over here, we can like put a title if you want to, but you will see the latitude, longitude. You can also replace the labels if you want to, but this is our image. And if you take a look to the folder, you will find the image as a PNG. So I hope that this video was useful for you. Don't forget to subscribe and hit the like button.